Hello students, in this video we'll discuss about optimization design. In my last video on optimization in pharmaceutical formulations, we were already get familiar with level, factor and response. So let us discuss the example of optimization design using 2⁵ factorial design. So here we'll take the example of preparation of the zolmitriptan microsphere using 2⁵ factorial design, and we'll find out the effect of variables and their interaction during the process of preparation of the microspheres. So the independent variables here will choose the chitosan, span-80 and Gultraldehyde, and we'll find out here which one is the best independent variable for the preparation of the microspheres. So as shown in this, the level of variable, as we already seen, chitosan, span-80 and the Gultraldehyde we have taken. So chitosan, it acts as this nothing but here one of the polymer, span-80 as the surfactant and the Gultraldehyde as a cross-linking agent. So this high level and the low level was selected by preparing the batches or making the changes in their quantity. So here the low layer was selected as 200 and high level 400 for chitosan, for span-80 low level as the 1% and high level as the 3%, whereas the Gultraldehyde 1 ml as well as the high level as 1.5%. by taking the number of batches or varying the changes in their quantity. Now next, according to that, this 2⁵ factorial design will prepare, and here when we kept all this chitosan as well as the span-80 and the Gultraldehyde in the low level as well as the maximum level concentration, we got this 8 batches. So 8 experts, these were selected, and again the students have to just keep it in mind. The low level, it's shown in design expert software as a -1, and the high level it's shown as the +1. Next thing, now as shown in this similar table, that is F1 to F8, these batches were generated with the quantities of these 3 variable, and after this responses, or what we can call as the dependent variable. So response 1 as well as the response 2 as selected, and it includes what here, that is entrapment efficiency and the percent drug release. Now as shown in this figure here, this percent entrapment efficiency and the percent drug release, this were determined for all the batches, and it put in design expert software 8 version or the advanced version also can be get utilized. After the preparation of batches and after evaluating all the responses, now we have to go for, that is the statistical design. And initially the first design, that is nothing but here the analysis of the variance as well as the model equation generated. So in this, the significance of the influence was statistically confirmed by ANOVA Test, and the model equation was obtained to get the fit result for the entrapment efficiency and even for the percent drug release, because as we already seen that we have chosen the response as the percent drug entrapment efficiency as well as what here, the percent drug release. So the equation is generated, which is given as follows, that is entrapment efficiency is equal to that equation. So here the plus sign, it indicates what, the synergistic effect, whereas the minus sign, it indicates what here, the antagonist effect, whereas A, B and C, this indicates what here, that is the levels or the independent variables. Now in this slide, that is the value of probability as shown in this ANOVA test. If it is less than 0.05, it indicates that model terms are significant. If we again in this also will get the R square value and it should be 0.099. So here this model, it shows the significant model if the value is less than 0.05. That is the significance of this ANOVA test. Next one is what here, that is design of experiment when we carried out the experimental variables. What is the effect of experimental variable on the response? So let us consider the first response as a polymer concentration. So this graphical representation, it shows that when we increases the polymer concentration, that is nothing but chitosan, it shows the increase in the drug entrapment efficiency. But whereas the concentration of polymer, when it decreases, the percent entrapment efficiency, again it will also decreases. So this is nothing but the effect of the polymer concentration on the percent entrapment efficiency. Now let us see the second variable, that is surfactant concentration. So as shown in the graph, it says that, or it shows that here, this as the surfactant concentration increases, the percent drug entrapment efficiency is what found to be decreases. Whereas when we increases the concentration of surfactant, that is whenever the concentration of surfactant decreases, the percent drug entrapment efficiency also get increases. So that is totally vice versa to that of the polymer concentration. Then third variable, cross-linking concentration. So as shown in the graph, as we increases the cross-linking agent concentration, percent drug entrapment efficiency, again it was found to be increases, whereas the concentration of cross-linking agent, when we decreases, the percent drug entrapment efficiency also get decreases. Now the next one is what here, the counter plot. So this counter plot, it shows the effect of polymer, surfactant and concentration of cross-linking agent on percent entrapment efficiency. So as shown in this counter plot, when the concentration of polymer was less, then the percent entrapment efficiency was also minimum. When the concentration was high, then percent entrapment efficiency was again in high range. Whereas we already seen that is the effect of variable. When we increases the surfactant concentration, again it shows the percent drug entrapment efficiency in decreased state. So again we observe same statement, that is a vice versa statement in this counter plot. Now the next one is what here, the 3D plot. So 3D response surface plot for the factorial model. These were drawn to show the effect of the variable on percent drug entrapment efficiency. So it illustrates the effect of polymer, surfactant and cross-linking agent on percent entrapment efficiency. So from this 3D plot, it demonstrates that the percent entrapment efficiency, it depends on both the polymer as well as the surfactant concentration. So as shown in this diagrammatic representation, when we increases the concentration of chitosan here, the percent entrapment efficiency again it increases. Whereas when we increases the concentration of the surfactant, that is the twin 80, the percent drug entrapment efficiency it decreases. So it already shown in this 3D plot. Next plot, that is nothing but again the percent drug entrapment efficiency with respect to that of the concentration of cross-linking agent and the surfactant. So again from this diagrammatic representation, it indicates that here when we increases the concentration of the Gultraldehyde, it shows that is the increase in percent entrapment efficiency. Whereas when we increases the span 80, that is the surfactant concentration, the percent entrapment efficiency it somehow decreases. So again this same effect shown in this 3D plot. Now after this, the diagnostic case statistics of the experimental matrix again will get in, that is the design expert software, and this diagnostic case statistics of experimental matrix where the actual value and the predicted value were compared, and here the less residual value batches, these are to be considered as better. So as shown in this table, F1 and F8 batch, it shows the actual value and the predicted value. So actual value, it is nothing but here whatever the value we are getting after performing the experiment, whereas the predicted value it obtained from the design expert software. So the comparison in between the actual value and the predicted value, if you see here the residual, that is the difference, it should be very less. That one it consider as a better. So in all these F1 to F8 batches, the residual value is very less. So what we can conclude, this model as well as the design is properly selected. After that, this is nothing but here the plot of the actual and the predicted value. It shows that all the points on straight line indicates the suitability of this design as well as the model. Next, the desirability approach. So desirability approach again is given by this software, and it indicates that here when the desirability range in between 0 to 1, that the most presumable answer will be the nearest to the 1. So if the desirability is 1, this indicates what here? This is the optimized solution. Next to that here, after preparation of all these or after getting the 3D plot, counter plot, we have to go for the validation of model. So in validation of model, this is carried out by selecting the batches which was provided by the software, and accordingly here we will selected the S2 and S25 batches, and the batches were prepared, and again the percent entrapment efficiency is determined for the both batches and the matches with the predicted response. So as shown in this diagram, that is the table, the predicted response and obtained response, these are nearer to each other, so residual is very less. So 3 times we have to that is evaluate this S2 as well as the S25 batch, and after that here the selected formulation in table, these are to be chosen for again the determination of percent entrapment efficiency, particle size determination, morphological evaluation by the same, then in vitro drug release study, the in vitro swelling capacity, as well as what? The in vitro mucoadhesion study, because we are preparing here the zolmitriptan, the microspheres. Now here in this video I have shown only one factor, that is percent entrapment efficiency. Similarly we have to carry out the ANOVA test, then again the counter plot, 3D plot, then actual predicted values as well as the diagnostic case for the percent drug release. So in this video we have seen all the parameters as well as what? The statistical design. So hope you will able to explain this optimization with the help of this 2⁻³ factorial design. So in my next video I will upload the 3⁻² design, 3⁻³ design by taking the example, and again one more video I will that is upload related to the full factorial design as well as what? The half factorial design. So thank you students.